Hi guys, welcome back to AMIE. So guys, in this video we are going to learn another non-traditional machining process, that is ultrasonic machining process. In this video we are going to learn the principle, the what kind of the equipments which is used to carry out this machining process, the working process, how does it works, and its applications as well as its merits and demerits, that is advantages and disadvantages. So guys, let's begin with our today's topic to learn the USM, that is ultrasonic machining. So guys, before going to our topic, I request you to please subscribe to my channel, educational channel, that is AMI. So guys, also press the bell icon so you will get notifications instantly. So let's begin with our today's topic. So guys, the USM is the ultrasonic machining process. It is a non-traditional or non-conventional machining process. Over here you can see these are the setup or the equipments over here in this image. So guys, it is a non-traditional machining process basically, which is used to carry out the machine on the brittle machining on the brittle and the hard material respectively. So guys, this machining process comes into the existence in the early 1950 for finishing the EDM surface, that is the electro discharge machining surface. And guys, this kind of the machining is adopted by a lot of industries due to its low cost, no heat generation on the surface of the workpiece, and this is very effective kind of machining process. So guys, let's begin with the principle of ultrasonic machining process. So over here in this image you can see these are the slurry and the abrasive particles are there. Also guys, this process works on the basic principle of the ultrasonic welding. If you know the ultrasonic welding, you might heard of ultrasonic machining as well. So in this machining process, it uses the ultrasonic waves to produce high frequency force of low amplitude. The driving force of the abrasive, this driving force of the abrasives is on the, produces the high frequency vibrating wave, that is of the frequency is about 20,000 to 30,000 hertz and amplitude is about 25 to 50 microns. This high frequency vibration transfers to the abrasive particles via tool which contains in the abrasive slurry. So guys, this leads the indentation of the abrasive particle on the brittle workpiece, and it removes the metal from the contact surface on the workpiece. So basically that was the principle of the USM. Let's check out the equipments which is used in ESM process. The first one and very necessary is our power source. So guys, as per our last machining processes, power source is very essential over here in this process. The machining process requires a high frequency ultrasonic waves which produces the high frequency ultrasonic waves. More the frequency, more the power supply required. This unit converts the low frequency electric voltage, that is 60 Hz, into high frequency electric voltage, that is 20 kHz. The next one is the magnetostrictive transducer. So as we all know, the transducer is a device which converts the one form of the electrical energy into the another form. Over here the electrical signal gets converted into the mechanical vibrations. In ultrasonic machining, the magneto strictive type of the transducer is used to generate the mechanical vibrations. So guys, this transducer is made by the nickel or nickel alloys, or it can be in the stainless steel as well. The next essential equipment is the booster. So guys, the mechanical vibration which are generated by the transducer is then passes through the booster, which amplifies it and then supply it to the horn. The next equipment is our tool. So the metal removal, or we can call it as the indentation by the abrasive particle, does not lead a brittle fracture of the tool. So the tool is made by tough, strong and the ductile material. The tool needs to be having higher hardness than that of the abrasive particles. The next one is the abrasive slurry. A water-based slurry of the abrasive particles is used as an abrasive slurry in the ultrasonic machining process basically. So guys, the silicon carbide or the aluminum oxide or Al2O3, boron carbide are used, that are the commonly used abrasive slurry over in the non-conventional machining processes. So guys, that was the equipments basically. Let's check out the working process. How does the actual process looks like? So guys, that is the setup over here in this image. You can see the material gets removed by the identification of the abrasive particles on the surface of the workpiece. Basically that is our principle. Let's check out the steps in the working. The first one is the electrical supply. So let's turn on the electrical supply. So that electrical supply produces the low frequency current in our system, and this low frequency current is then converted into the high frequency current by some sort of the electrical equipments. Then this high frequency current is then transfers to the transducer, which converts the one form of energy to the another form, that is the frequency of the electrical signal. It converts into the high frequency mechanical vibrations. So guys, this vibration is then transfers to the booster, or we can call it as a horn, which then amplifies this mechanical vibration. So booster amplifies this high frequency vibrations in this USM process and then send it to the horn. So guys, the horn is a device which is connected to the workpiece. The horn is a device which is connected to the tool. The horn can be also known as a tool holder basically. So guys, the tool vibrates at higher mechanical frequency. So guys, tool tends to it vibrates the abrasives, that is the abrasive particles, at higher frequency, and that's how the abrasive gets strikes on the surface of the workpiece. Of course, then metal removal will take place on the surface of the workpiece. So guys, that was the working process. Let's check out the application of the ultrasonic machining process. So guys, the machining is used, this kind of the machining is used to machine the hard and brittle materials like the carbide, ceramics, glasses. So these are all the non-metals guys. Metal can be used, but these are all the non-metals. This is used for the machining of the die and tool of drill, wire drawing machine, etc. Also this can be used for the manufacturing of these turbine blades that can be called as the silicon nitrile turbine blades, which is used in the turbocharger. And also guys, this can be used to machine the diamond cutting. We can use this kind of process, that is the ultrasonic machining process. So guys, basically this USM is used for machining the non-conductive materials such as, whereas in case of ECM and EDM we can only machine the conductive material. So basically that is the only advantage over here. So let's talk about the advantage and disadvantage. So guys, in terms of advantages, the hard metal can be easily machined over here by using this USM process. No heat generated in the work, so there is no problem of the work hardening or the change in the structure of the workpiece due to heat. So guys, this is the non-conductive material can be machined very easily. Non-metals can be machined very easily. Ceramics over here we can machine that kind of stuff. There is no chip formation in this kind of machining process. So guys, that was the advantages. Let's talk about the disadvantages. It's a slow process and it's a time consuming process. It takes more time. So basically that is the major disadvantage over here. The high tool wear due to the abrasives. Also guys, the abrasive strikes on the surface of the workpiece, so it strikes on the surface of the tool as well. So high tool wear, it cannot machine the ductile material. And guys, the deeper hole cannot be drilled over here. So guys, that was the basic advantages and disadvantages. So guys, we have seen all about the ultrasonic machining process. I hope you liked my video. Please do subscribe to my channel AMIE. So guys, thank you for watching my video. Please do subscribe to my channel. Thank you.